Good morning, students. Write your
Good
name
morning, sir.
number in the chat box. आवाज येते का? Yes, tell me, screen is visible.
Yes.
दोन मिनिट वाट बघू आपण. 32 मुलं जॉईन झालेली, 32. ठीक आहे, सुरू करू आपण आता. So in the previous lectures, we already learned about the alkenes and alkenes. Anyone can tell me the definition of alkanes? So we will start.
They are pi bond and are unsaturated.
Yes, tell me again.
They have the pi bond and they are unsaturated
Alkanes,
hydrocarbon.
alkanes. I am talking about the alkanes. ANE.
Oh, they are sigma bond and they are saturated hydrocarbons.
Okay. What about the alkenes?
Pi bond
They
and
have
unsaturated.
pi bond and unsaturated hydrocarbon.
Okay, means carbon-carbon double bond is present in case of alkenes, and carbon-carbon single bond is present in case of alkanes. So the alkanes are called as aliphatic saturated hydrocarbons, and alkenes are called as aliphatic unsaturated hydrocarbons. Unsaturated means there may be a carbon-carbon double bond or single bond. So these alkynes are also the aliphatic unsaturated hydrocarbons, but the condition is very important. At least one carbon-carbon triple bond should be there. And see, the general formula is CnH2n minus 2, where n represents the number of carbon atoms. Then isomerism of alkanes. Now we are familiar with this word isomerism because this isomerism is discussed from the chapter number 13. We discussed the isomerism of alkanes. We discussed the isomerism of alkenes also. There are different isomers, chain isomers, then position isomers. These are the types of structural isomers. So in this alkynes also, it shows the position isomerism, which is a type of structural isomerism. See here, structure is shown, and here the IUPAC name. See, first one, in the first compound, there are 5 carbons. In the second compound, there are also 5 carbons. This is pent 1YNE. Only one difference is there. See the position of the double bond here. Position of the triple bond here is on the carbon number 1. But in the second compound, we can see the position of the carbon-carbon triple bond is on the second carbon. So the position of the carbon-carbon triple bond is changed. Such type of isomers means this compound number 1 and compound number 2, these are called as position isomers because the position of double bond is only changed. The molecular formula is same. 5 carbons are also there. In the second compound also 5 carbons are there. But see, the third structure is quite different. 4 carbons are in the straight chain. So the compound number 1 and the compound number 3, these are the examples of chain isomers because the chain carbon chain is different. There are 5 carbons and there are 4 carbons. So example number 1 and this compound number 3, these are the examples of chain isomers. Also, the second one and third one are the examples of chain isomers because the chain carbon chain is different. 4 carbons are there in the straight chain and there are 5 carbons in the straight chain. And if the position of the triple bond is changed, it is called a position isomer. So remember these examples, pent 1 YNE. According to the nomenclature of IUPAC, the triple bonded carbon should get lowest number. So this will be carbon number 1, 2, 3, 4, 5. Pent because 5 carbons. 1 indicates on the carbon number 1 there is triple bond and it ends with YNE. Remember, alkene ends with ENE, alkane ends with ANE, and this alkyne ends with YNE. See the difference. This is pent to YNE because second carbon having the triple bond, and this is 3-methyl but 1 YN because but indicates there should be a 4 carbons in the longest chain. So this is a 1, 2, 3, 4, and the lowest numbering should be start from the carbon which is having the carbon-carbon triple bond. So this is 1, 2, 3, 4 on the carbon number 3, methyl group is there. So the name is 3-methyl but YNE. There are some examples are given. Lower alkynes, C2H2, it is a common name. It is acetylene. Mostly this acetylene is a gas. This name is used. The IUPAC name is ethine. When there is a 3 carbons, the name is methyl acetylene. See, methyl acetylene is a common name because methyl group is added in the acetylene. This is acetylene, parent acetylene, C2 and H2. But when the methyl group is added, the common name is methyl acetylene, and see the IUPAC name is propyne because there are 3 carbons. When there are 4 carbons, it is butane, but position is important. But YNE, but 1 YNE indicates there is a carbon-carbon triple bond on the first carbon. See, this is 1, 2, 3, 4. So that's why it is but 1 YNE. This is but 2 YNE means, see here, the second carbon having the carbon-carbon triple bond. This is number 1, 2, 3, 4. Or you can give the numbering from right hand side or left hand side because it is symmetrical alkyne. Then methods of preparation of alkynes. First one is industrial source. First one is industrial source. It is deleted from the syllabus. No any question will be asked from industrial source. We will start from this, from calcium carbide. So we can prepare the alkynes, means the compounds which is having carbon-carbon triple bond, by using calcium carbide. So this is the formula of calcium carbide, CaC2. Industrially, ethine is prepared by the reaction of calcium carbide with water. When calcium carbide reacts with water, we get acetylene gas. We get, this is acetylene. C2H2 means this is acetylene. So this is a calcium carbide. When water is added, we get here C2H2. C2H2 is nothing but C triple bond C and HH. Condensed formula is written here. See the condensed formula. And here extended formula is written. See the acetylene C2H2 here. जे इथे ट्रिपल बॉन्ड दाखवलेला नाहीये, लक्षात घ्या. But this is acetylene and this is a byproduct. Calcium hydroxide is a byproduct. So this is the first method, and industrially acetylene it is prepared by using this method. Then second one, so industrial method is completed. Then next one, by dehydrohalogenation of vicinal dihalides. D means we have to remove. What we have to remove? Hydrohalogenation. Hydrogen and halogenation we have to remove of vicinal dihalides. Now this is a new concept, vicinal dihalides. Dihalides means 2 halides are there. But vicinal I will explain when there are 2 halides on the adjacent carbon atom. It is called as vicinal. And when two dihalides are present on the same carbon atom, it is called as geminal dihalides. Remember the difference between geminal and vicinal. Vicinal means two halogens are present on the adjacent carbon atom. I will give you one example. So, dehydrohalogenation means we have to remove the hydrogen and halogen. Removal of hydrogen and X means halogen from the adjacent carbon. It is called as dehydrohalogenation reaction. See this example, vicinal dihalides. Already I explained vicinal means when the two halogens are present on the adjacent carbon. So this is a, we can see two X are there. This is a one X. I will show with the red color. See this one, this X, and see this X, two X are there. And these two X are present on the different carbons. But these should be adjacent carbon. This is the first carbon and this is adjacent carbon. When these two X are attached on the different carbons, but this different carbon should be adjacent to each other. जवळ जवळ पाहिजेत. नाहीतर इथे एखादा कार्बन असेल आणि दुसरा इकडे लांब असेल तर त्याला विसिनल आपण म्हणत नाही, लक्षात घ्या. इट इज नॉट विसिनल. So the condition of vicinal should be the two halogens should be present on the adjacent carbon. Different carbon हा शब्द वापरलेला नाहीये मी, लक्षात घ्या. Adjacent म्हणजे हे कार्बन जवळ जवळ असले पाहिजे. So in this reaction, dehydrohalogenation takes place, means hydrogen from one carbon and halogen from another carbon we have to remove. When this is removed, we get here double bond. So double bond will be appeared here. So from the vicinal dihalide, the conditions, see the conditions are very important. We have to use alcoholic solution of potassium hydroxide. Potassium hydroxide, this is a base. Potassium hydroxide, it is a base. So in the first step, we have to use the potassium hydroxide. So potassium hydroxide, in which the potassium is there and OH is there. So this K will combine with this X, and this is minus KX, and this OH will combine with this hydrogen, and water molecule will be removed, KX molecule will be removed, and we get here double bond. But we have to prepare the alkynes, means again we have to remove the dehydrohalogenation two times. Two times we have to remove the hydrogen and halogens. If you remove one hydrogen and one halogen, we get here double bond. Again, we have to remove this hydrogen and this halogen. Then we'll get the triple bond in the final compound. See here, triple bond. So this hydrogen and this halogen will be removed. So the strong base we have to use in the second step. In the first step, we can remove by using potassium hydroxide, but potassium hydroxide cannot work in the second step because this is more acidic. This hydrogen becomes more acidic, the compounds become stable. So another strong base we have to use. The name of the strong base is sodamide. This sodamide, it is a combination of sodium and NH2. This is called a soda and this is mide, sodamide. The sodamide is a strong base which is used in the second step. In the first step, we have to use KOH. In the second step, we have to use this sodamide. So what is the role of this sodamide? Again, to remove the hydrogen and halogen. Sodamideचं काम काय आहे की हायड्रोजन आणि हॅलोजन रिमूव्ह करायचं. So this Na will combine with this X, NaCl, and ammonia gas. It is removed and we get here carbon-carbon triple bond. So this is a two-step reaction. Two hydrogens and two halogens will be removed. This is called as dehydrohalogenation reaction. The examples are given here. See here, 1,2-dibromoethane, bromine. This is another bromine. These are bonded to the carbon atom, adjacent carbon atom. So these are vicinal dihalides. Dihalides means two halogens are there. See, according to the general reaction, alcoholic KOH is used. The role of alcoholic KOH is first step. In the first step, hydrogen and one bromine will be removed. We get here double bond. And in the second step, one hydrogen and this bromine will be removed by using this NaNH2. This is sodamide. And final product we will get here alkyne. The name of alkyne is ethyne. So at your home, we can make a practice of the different. We can take a different dihalides. We can take here instead of bromine, we can take chlorine also, and make a practice. Then next second method is from terminal alkynes. So terminal alkynes, I will explain what is mean by terminal alkynes. The terminal alkynes are the compounds in which hydrogen atom is directly bonded to the triply bonded carbon atom. See these two examples are given. In the first example, hydrogen is directly bonded to this carbon. And in the second example, this hydrogen is also bonded to this carbon. So the hydrogen atom which is directly bonded to this triply bonded carbon atom is more acidic. More acidic means it will be removed easily. Acidic hydrogen means this hydrogen will be removed easily with the action of strong base. म्हणजे काय असतं की हा हायड्रोजन लगेच रिमूव्ह होतो, लक्षात घ्या, म्हणून त्याला ऍसिडिक हायड्रोजन म्हणतात. Acidic hydrogen is that hydrogen which is donated easily. That is called as acidic hydrogen. So in this method, the smaller terminal alkyne first reacts with very strong base like lithium amide. Lithium amide is a base here. See this example. This is a terminal alkyne. Why this is a terminal alkyne? Because the hydrogen is directly bonded to this carbon. Hydrogen is bonded to the carbon-carbon triple bond. So this hydrogen is acidic. This is easily removed by using the strong base lithium amide. So lithium amide is also the similar type of base like sodium amide. In the previous example, we have used the base sodium amide. In this, we are using this lithium amide. So lithium amide is quite easy to handle, than the sodium amide. So it is mentioned here, lithium amide is easier to handle than sodium amide. But we can use here lithium amide also, we can use here sodium amide. But the specific conditions are given. It is very easy to handle. That's why we are using this lithium amide. So in this reaction, say this lithium or this hydrogen will be removed by this NH2 group, and we get here NH3. And the first product we get here, it is called as metal acetylide. The name of the compound is metal acetylide. म्हणजे याच्यामध्ये काय होतं, हा lithium, it is attached to the carbon. Lithium is a metal, so that's why the common name of this compound is metal acetylide. Metal acetylide, these compounds are formed. See here, lithium is there and NH3 is removed. Then this metal acetylide, or it is also called as alkynyl 1YL lithium, it reacts with another alkyl halide. So RX is another alkyl halide. So lithium will combine with this X, and this R dash will be bonded to this carbon. Come to the one example, then we'll understand. So see here, this is one terminal alkyne is taken. The name is ethyne. So in the first step, what will happen? This NH2 will pick up this proton, and we get here ethynylium ion. See the name. The names are quite difficult to understand. Ethynylium. Ethynylium means this is a actually ethene and lithium. So this is a combination of ethene and lithium. So it is called as ethynylium. So this is the first step. In the second step, it reacts with one alkyl halide. So this is a bromoethane. So lithium will combine with this bromine, and this CH3, CH2 will be attached here, and we get here but1YNE. So this is a alkyne. What is the name of this alkyne? But1YNE, because 1, 2, 3, 4 carbons are there, and on the carbon number 1 there is a triple bond. That's why it is but1YNE, and this is a byproduct, lithium bromide. So we can take here different examples. We can take here propine, we can take here butane, and we can do the reactions up to the carbon number 7, carbon number 8, carbon number 9. We can do this reaction. So make a practice of this reaction. Take different examples at your home and you can solve. Because two examples already I have given here, ethyne, propine in your home. You can take butane, pentane, hexane, and we can do the reaction. Make a practice. Then physical properties of the alkynes, physical properties are similar to alkanes. Alkenes are same because all these are hydrocarbons. All these are non-polar, so physical properties are same. These are less dense than water, so density is less. They are insoluble in water because these are not polar. These are soluble in less polar organic solvents like ether, benzene, carbon tetrachloride. Because there is one rule: polar compounds dissolve in polar solvents, non-polar dissolves in non-polar solvents. So as it is non-polar, it will be dissolved in non-polar solvents like this benzene, carbon tetrachloride, ether. These are non-polar, and water is polar. So these melting points and boiling points of these alkynes increases with increase in molecular mass. See here, ethine, propine, butane, pentane, and this is molecular mass is shown here 26, 40, 54. It is increasing. So as the molecular mass increasing, the physical states are given. Ethine is a gas, propane is a gas, butane is a gas, and these are liquids. This is a liquid. Pent 1 ion is liquid. Hexane is liquid. Similar to the alkanes, these are also the first three members are gaseous. Then next up to 17, these are liquids, and after that it is solids. Then see this melting point is increasing. 198, 250, 282, 313, 345. So the boiling points are also increasing. The melting points are, but this melting point shows different trends here. We can see, but boiling points are increasing. Boiling points are increasing at the molecular mass is increasing, but here we can see the trends is not similar to the melting point because the surface area is also responsible for this. In the first part, alkanes, we discuss about the surface area. When the long chain alkanes are there, they have higher number of melting points because they requires more temperature to melt because surface area is larger. So van der Waals forces, there are the van der Waals forces are quite stronger in case of long chain. So remember one thing: when the surface area is large, the melting point will be more melting point, and if the surface area is less, they will be easily they will get easily melted. So the its melting point will be less. Then I'm coming to the chemical properties. Just I discuss about the one chemical property, the carbon atom. See, I will explain this one. The carbon atom which is bounded to this terminal carbon which is more acidic. This is already explained because this carbon, triple bonded carbon is more electronegative than the carbon present in alkene and the carbon present in alkanes. So this hydrogen is more acidic. So this is the first property, remember. This is acidity of alkyne. This explanation, same explanation I have given. This carbon is more electronegative than the carbon which is present in alkene and alkynes. So because this is sp hybridized, hybridization we will discuss in the chapter number 6, that is the chemical bonding. But remember, when the carbon-carbon single bond is there, the hybridization is sp3. When the carbon-carbon double bond is there, the hybridization is sp2. And when the carbon-carbon triple bond is there, the hybridization is sp. So here, this carbon is sp hybridized. When this hydrogen is directly attached to sp hybridized carbon atom, it is more acidic because this carbon is more electronegative. Why this is more electronegative? Because the carbon, so electrons are present in this carbon. These are closer to the nucleus and these are tightly held. So it becomes more electronegative. हे डिटेल एक्सप्लेनेशन सांगितले मी, तर हे ज्यांना समजते त्यांनी लक्षात ठेवा. बाकीच्यांनी जर समजलं नाही तर लक्षात ठेवा. हा हायड्रोजन ऍसिडिक असतो. का असतो? तर हा इलेक्ट्रोनिगेटिव्ह असतो म्हणून. हा इलेक्ट्रोनिगेटिव्ह का असतो? कारण याच्यामधले जे इलेक्ट्रॉन असतात ते न्यूक्लियसच्या जवळ असतात. याची सगळ्याची उत्तरं दिलेली आहेत मी. आता तो हायड्रोजन ऍसिडिक असल्यामुळे काय होतं? इट इझिली रिॲक्ट्स विथ द बेस and it will be easily removed. It will be easily removed. So we clearly see in this example, this is a lithium amide is a strong base. So this lithium again it will be combined. So previously already I explained this reaction. Previously I already explained this reaction and we get here. lithium propionide. And see the relative acidity of the alkenes and alkynes is given. So this clearly we can see the alkynes are more acidic than alkenes, and alkanes carbon carbon single bond वाले कार्बन कार्बन सिंगल बॉन्ड वाली जो है तो least acidic है. These are the least acidic. See, because this carbon is sp3 hybridized, this carbon is sp2 hybridized, and this carbon is sp hybridized. So acidic nature, this is actually not asked for the examination, but you should know why this is acidic. The next one is addition of dihydrogen. Addition of dihydrogen. Yes, anyone having the difficulties? Bhumi Dharma would tell me you understand why these hydrogens are acidic. Patil Arjun, tell me, anyone? Why the hydrogens attached to the carbon-carbon triple bond are more acidic?
Sir, because they are electronegative carbon.
Very good. And why that carbon is electronegative?
Electrons are closer to the nucleus.
Very good. म्हणजे कळतंय तुम्हाला. ठीक आहे, पुढची रिएक्शन आपण बघूया. ऍडिशन ऑफ डायहायड्रोजन. डायहायड्रोजन म्हणजे इथे आपल्याला हायड्रोजन ऍड करायचं आहे, त्यालाच अनदर नेम आहे हायड्रोजिनेशन. Hydrogenation means we are adding hydrogens, and dehydrogenation means when the D word is there, it is meaning is we have to remove the groups. Dehydrogenation means removal of H2. Hydrogenation means addition of H2. Decarboxylation means removal of CO2. Carboxylation means addition of CO2. Dehydrohalogenation means removal of hydrogen and halogen. And halogenation means addition of halogen. Hydrohalogenation means addition of hydrogen and halogen. ह्या कॉन्सेप्ट लक्षात ठेवा. हायड्रोजिनेशन, हॅलोजिनेशन, कार्बोक्सिलेशन, आणि त्याच्या अगोदर डी लावलं की ते काढून टाकायचं. डी मीन्स रिमूव्ह. डीई मीन्स वी हॅव टू रिमूव्ह, अँड विदाउट डीई मीन्स वी हॅव टू ऍड. So here addition of dihydrogen. So this reaction is also called as hydrogenation. So one example is given. When acetylene, what is the another name of acetylene? Anyone can tell me? First, लवकर सांगायचं. Acetylene, another name of acetylene. This is the first member of alkynes. Acetylene, it is a common name. What is the IUPAC name of acetylene? Ethine. Very good. Very good. Very good. Ethine, correct. Ethine is heated with hydrogen gas in presence of catalyst. We discuss in this reaction in the methods of preparation of alkynes also. When the triple bond we have to convert, when the hydrogen is added and these catalysts are used, ranny nickel or platinum or palladium. See here, these are the different catalysts. Actually the ranny nickel, this reaction takes place at higher temperature, but this platinum and palladium reaction takes place at room temperatures. So this triple bond is converted into single bond. This reaction is already completed in this methods of preparation of alkanes by using hydrocarbons. So what is the role of this platinum and palladium? These are the catalyst and hydrogenation, catalytic hydrogenation. It is also called as catalytic hydrogenation, means addition of hydrogen in presence of catalyst. So in the first step, H2, 2 hydrogens are added, we get alkene. Again 2 hydrogens are added, we get here alkane. So here total 1, 2, 3, 4 hydrogens we have to add. It means twice H2. Directly here, if you write twice H2, first step to direct we can convert to alkene into alkanes. So this preparation can be asked for the exam. How will you prepare ethane? Final product is ethane. We can see here final product is ethane, and the first raw material is acetylene. So question can be asked for the exam. How will you prepare ethane by using acetylene? So we have to remember this H2 and catalyst. Sorry. Then number 3 reaction is addition of halogens. So when the addition of halogens, it is called as halogenation, like hydrogenation. When addition of hydrogen is there, it is a hydrogenation. In this halogens we have to add. See, this is again the general reaction I will explain. This is a carbon-carbon triple bond is alkyne. X2, here X2 means halogens. Chlorine, bromine or iodine you can add. CCl4, it is used as a solvent only. There is no role of this CCl4. It is inert solvent. Carbon tetrachloride, instead of this carbon tetrachloride, we can use hexanals. So in the first step, these two halogens are added to this two carbons. Again, halogenation takes place, and this is the final product. Means we get here 1,1,2,2 tetrahaloalkane. Means the addition of halogen takes place when up to triple bond is converted into double bond and double bond is converted into single bond. म्हणजे 4 halogens इथं add झालेले लक्षात घ्या. So this is one example is given. Ethine reacts with bromine because we are adding here bromine in the inert solvent carbon tetrachloride to give tetrabromoethane. So in the first step we get here 1,2-dibromo. These two bromines are added on this carbon-carbon triple bond. So triple bond is converted into double bond in the first step, and this double bond is converted into single bond. This is 1,1, see 1,1,2,2 tetrabromo propane. So this bromine reaction, actually this bromine is a tough red colored liquid. ब्रोमीन हे रेड कलरचं लिक्विड असतं आणि रिॲक्शनचा जर आफ्टर प्रोडक्टचा जर रंग बदलला तर आपण असं ओळखू शकतो की दॅट कंपाऊंड शुड कंटेन the carbon-carbon double bond or carbon-carbon triple bond. So this is a very useful test for the detection of unsaturation. Bromine ची टेस्ट आपण unsaturation साठी वापरतो, लक्षात घ्या. So red color of the solution
Sir.
of, हा बोला.
सर ऐका ना, आपण जर तुम्ही